Okay, sorry for the impromptu speech here, but I was unable to be in class tonight, and I'm giving my presentation via the web. So I did my research on tropical cyclones. First part I'll go over is how the phenomena develops. There's many stages to a tropical cyclone. It's just like a hurricane. First it starts out as a thunderstorm out at sea, and it becomes organized and could possibly, the thunderstorms become more organized and they become tropical depression, and then it actually becomes, after that, a tropical storm when the storm becomes even more organized than before and the winds are increasing. There's different wind speeds, and I believe once it hits certain stages, then you are classified as a different storm. So you start out as a tropical depression, then you go to a tropical storm, and then finally you get to a hurricane, or a hurricane/cyclone, tropical cyclone. And as you can see right here, this shows how the cyclones put together. As you can see, tropical cyclones form from condensation off of the ocean from latent heat, and the latent heat actually builds the storm up, and the more water it takes in and it absorbs, the more the storm will grow and become intense. As you can see here, it spins around with spiral rain bands on the outside, and then the air will also spiral up the center into unstable atmosphere air up in the tropopause, and then it'll actually, some of it will fall back down, and then you'll get a very defined eye wall. So then the eye will be in the center, and then you'll have the outflow at the top that comes out, hits that layer of air, the high pressure, and flows out. So there you see that's the mechanisms of a tropical cyclone. I found that on maps of the world. Next, we'll look at the historical distribution. Basically, this map I found on Google, and it's a very nice map because it actually shows you where every single hurricane/tropical storm has been since 1985 to the current day. As you can see, in the U.S., it starts out over in Africa and heads in toward the coast, and some scatter out up into the North Atlantic. Then you get some down in the Pacific that come in and fully concentrate on lower Mexico and Baja, Mexico. And then, as you can see, the region that has the most by far is this region over here in Asia. It's very, very tightly clustered. And you actually can tell off of this map, no tropical cyclones or hurricanes will actually form in this region down here because it's too close to the equator and there's not enough Coriolis effect, so that way it doesn't give it the spin. So no tropical storm, or very few, ever form down here in this region. And you actually can tell, like I said, that the majority of these storms are right in here. So you can see that this area has just been impacted greatly by these tropical storms, and you can't even see some of the islands that are down there, like the Philippines and certain parts of Vietnam and areas, because it's just been totally consumed over by all these tropical cyclones. And then once again, you see there's very few down here in the Indian Ocean basin. So that is the historical distribution. There's been very, very many deadly tropical storms. I use hurricane and tropical storms in and out because it's basically the same thing, just called differently in different parts of the world. So you have all this up here, and then, like I say, once it hits this, there's nothing really stopping it. There's nothing to cause it to fall apart because the size of the landmass is not large enough to actually cause it to lose any of its power. So once it hits land, it goes over it, and then all of a sudden hits water again and regains strength. So that's the reason there's probably so many down here, is because you got the nice warm water, and then you have steering winds as well. When you look at the factors that determine the risks, basically what's at risk, there's no way to really mitigate these storms. It's been tried. I'll go over that in the next slide. But determining the risk, over in Southeast Asia, there's very, very lax building codes. So basically, when you get over there, you're not really building houses that are going to be able to withstand 200-mile-an-hour winds. The coastal layout, more people are moving toward the coasts, and these islands and nations are so small that when these tropical storms hit, it's just so devastating because they never lose any of their power until they get into a large tract of land. So I would say that with all the people that live on the coasts. And then the emergency preparedness. Most places aren't very prepared for something like this when they have to evacuate. It's a mass evacuation, and you actually have very little time to, well, I mean, there's enough time to get out, they give you enough 24-hour notice, but just the infrastructure itself isn't capable of handling a mass evacuation. And due to the large populations of the poor, it's very hard for them to get out, so they're affected greatly. And then early warning and tracking centers, of the 9 warning centers in the world, only 4 of them are designed and set up to actually track and set out warnings to the public for tropical cyclones. So not to say that these places, like the other 5 warning centers, don't do that too, but it's their primary responsibility in those 4 warning centers to set out the warnings. The mitigation of the risks, how can we get rid of them? They need to start designing structures just like the U.S. It may cost a little more, but it's going to actually end up saving lives and prevent property damage. And I mean, in Florida alone, public structures are designed to withstand up to a 200-mile-an-hour wind. So, I mean, with those changes, you actually be able to make make it easier for people not to have to leave and have safety and structures along the areas for people who can't get away. Early warning and mandatory evacuation plans. This would be helpful because we get people that are in harm's way along the coast away from the areas that they are in, that are in danger. And like they say, the leading killer of storms in the coastal areas is a storm surge, because nobody really predicts it to happen, and it comes in with such force that nobody has time to get away from it. Also, they've tried, in the U.S., in the 1980s, they tried a thing called cloud seeding, and it was called Project Storm Fury, where they actually started cloud seeding some of the hurricanes to try to freeze the outer rain bands and artificially dissipate the storm. It actually did work for the times that they were cloud seeding, but they found that they would have to cloud seed continuously for it to be effective, because as soon as they stopped, the storm just gained all of its power back and then actually hit another, like kind of changed track and hit someplace that they didn't really predict it was going to hit. So that would be something that they would look into, but probably not for economic standpoints very feasible for the amount of storms we have and they have. The biggest thing is better tracking of the storms and strengthen the buildings. That would be the way to mitigate the current risks that they have associated with tropical cyclones. So I hope I informed you a little bit about my research paper and tropical cyclones, and I'm sure that you guys have a little bit more to add to it. Anyway, thanks for your time.